Hello everyone, in this video we are going to see about the full subtractor. Last videos we have seen about the full adder which adds three numbers. Here we are using the three inputs for subtraction. So it is a full subtractor. A full subtractor is a combinational circuit that performs a subtraction of two bits. One is minuend and other is the subtrahend, taking into account borrow of the previous adjacent lower minuend bit. Okay, now here the circuit has three inputs and two outputs. The three inputs are A, B and borrow in, which is B in, denotes the minuend, subtrahend and the previous borrow respectively, and the two outputs are the difference and the borrow. Okay, let us see how the truth table of this full subtractor is formed, and before that we see the block diagram and the gate diagram of the full subtractor. Here the full subtractor has three inputs and two outputs. A and B are the subtrahend and the minuend, and B in is the borrow from the previous bit. So since it processes three inputs, it's a full subtractor, and the outputs are D and B out. D is the difference and B is the borrow. Okay, let us see now this gate diagram of the full subtractor. There are two XOR gate which helps to subtract the three numbers. Okay, so initially A and B are XOR to find the difference, and the difference of this output is with the B in is done by the another XOR gate. So this XOR gate find the difference between A and B, and this output and along with the B in, this second XOR gate find out the difference between the answer from the first XOR gate and the B in, borrow in, okay, which is the borrow from the previous bit. And how the borrow out is formed? The borrow out is formed by OR, by using the OR function, OR gate, which are the value from two input AND gates. Okay, so this input AND gate and this is the another input AND gate which gives the input to this OR gate to find out the original borrow, which is the borrow out. Let us see how the, and here we can also see that this input is of this is A bar B. Okay, so we have seen in the previous videos for the half subtractor the difference is A XOR B and the carry is A bar into B. So here the same thing for it. So you can see that this full subtractor is the combination of two half subtractor. This area alone will form a half subtractor, and this alone will form a next half subtractor. The combining this first half subtractor plus the next half subtractor by the OR gate will give the functionality of the full subtractor. Let us see how the truth table is formed from the basic binary subtraction. 0 minus 0 is 0, 0 minus 1 is 1 with a borrow 1, and 1 minus 0 is 1 and 1 minus 1 is 0. So we have to form the three variable Karnaugh map. So we have to first form the truth table with the three inputs having 7 combinations, 2 power 3 which is 8 combination, value from 0 to 7. Okay, so first you have to fill in the input values A, B, which is the borrow in. Okay, so for that we have to find out the, write the binary equivalent of the numbers from 0 to 7. As we know that for 3 variable map we have 2 power 3 8 combinations which ranges from 0 to 7. So which is 0 0 0 0 0 1 0 1 0 0 1 1 1 0 0 1 0 1 1 1 0 and 1 1 1. These are all the binary values of 0 1 2 3 4 5 6 and 7. So all the inputs are filled over here. Now how to form the output? So first the value subtracted from these two columns, from this answer this column and this column the answer is derived. For example, take this example of this column. 0 minus 0 is 0 and From this 0 minus 0 is 0. So we haven't borrowed anything, so the borrow is also 0. Okay. So now take the next example. 0 minus 0 is 0. There is no borrow. But now when you're subtracting this 0 minus 1, we have getting a borrow and as well as the difference. So 0 minus 1 is 1 with the difference 1. So we are getting a borrow 1 and also a difference 1 and the borrow 1. Okay. So here likewise we have to subtract the first two digits. From the answer we have to subtract the next digit. So randomly take this example of this last one, 111. 1 minus 1 is 0. Okay, and from this 0 we got to subtract this 1. So 0 minus 1 is 1 with a borrow 1. So we have, this is the way we have to find out the subtraction between the two inputs as well as the borrow in, and we have to fill the output column. Now let us find out the equation for this difference and the carry by using the Karnaugh map. We know that Karnaugh map is a pictorial representation to find out the simplified expression of any Boolean expression. Let us see how to find out the Karnaugh map, how to draw the Karnaugh map and find the expression for the difference in this slide. Okay, so now first from this truth table take only the difference column alone. For this case, for here, and we know that we have three variables, so the combinations are 2 power 3, which is 0 to 7. So we have to draw the Karnaugh map this way. The 8 cells 0, 1, 2, 3, 4, 5, 6, 7. This is the way we always name the Karnaugh map. Okay. So how to use the labeling? A bar A, and this is B bar in, then B bar and then B in, and this is B in, and this is B bar in. Okay, so now we have to write the labels as well as the fill the values. So for this D, the answer here are for the position 1, for the position 2, and for 4 and for 7. So for 1, 2, 4 and 7, the values are 1. So you have to fill the values. So the positions are 0, 1, 2, 3, 4, 5, 6, 7. So fill in the values for 1, 2, 4 and 7 with the 1 and leave the remaining as blank, or we can fill the value as 0. Okay, now we can see that after filling this Karnaugh map, there is no adjacent ones to make any group like a pair or a quad or an octet. There is no possibility here. We can make only a singlet because there is no adjacent one, but they are in the diagonal way, which is not the way to combine the values to form the group. So we can form only the singlets here. So this is one singlet and another singlet, singlet 3 and singlet 4. So we have to find the equation for these singlets individually, and we have to join the equation by the plus. Okay, so here we can see this. For this singlet, the value is A bar from this position bar, and then for this is actually B bar and B in. Okay, so the answer is A bar, B in. So first term is A bar, B in, plus take the next term. Here this is A bar and this is B and then B bar in. So it is given as A, this term A bar, B in bar. Likewise A, B in. For this singlet, this is actually A from this row, and this row it is B and B in. So A, B in. And for this term, this is actually A here, and this term is B bar in, B bar and B bar in. So A, B bar in. So it is given as A, B bar in, and then A bar, B in bar. So we have to write the terms from this singlets individually, and we have to join these four terms using the plus operator. 1, 2, 3, 4 inputs or 4 singlet equations are joined by the plus operator. So the difference equation is formed. This is what given over here. So first write this equation from this singlet, and we have to combine the equations using the common terms, taking the common terms outside. So taking this b in outside, we are having two terms, a bar b bar plus ab, and taking b in bar outside, we are having ab bar plus a bar b. Okay, now how to simplify the expression? This is actually a bar b bar plus ab is XNOR operation, and ab bar plus a bar b is XOR operation. So write the equation in terms of simplified form as XNOR. So keep the b in as it is. For this a bar b bar plus ab, we can substitute XNOR. So a XNOR b plus b in bar you write as it is, and for ab bar plus a bar b, the expression is XOR. So a XOR b. And now we can write this way, b in into a XOR b the whole bar, okay, plus b in bar a XOR b. Here we are just to change for XNOR, instead we are putting XOR bar, because we know that X bar and to the we are, if you not the XOR value, it is XNOR. Okay, so instead of writing as XNOR, here we are using XOR term, so we are compensating that by writing the bar here. Okay, so this we have written to make this value equal to this value to simplify the expression, then which is equal to b in, this is actually a XOR b plus a XOR b. Okay, so actually this is, if you take this is one term, a b bar plus a bar b. If you suppose, if you take this whole bin as x and this a XOR b as y, we can write as x y bar plus x bar y, which is the XOR function of both the terms. So we can write as b in XOR of a XOR b. So finally, by simplifying this, we are getting this term as bin into, that is the b input into XOR of a XOR b. So that is what we are using the two XOR gates. First we XOR a and b, and that output is XOR with the binary, which is the borrow in value. So we are having the two successive XOR functionalities given over here. So we can write other way also, because they are we can write it as a composite operation. So we can write a XOR b is also same as b XOR a. So we are just changing the position of this a XOR b, and we are writing this bin over here. So this is the final expression for the difference a XOR b, and from that we are XORing the answer with the borrow in. So this is how the difference equation is formed. Same way we can find out the expression for the borrow. So how to write the borrow expression? Same way, you fill the value truth table, and now you take only the borrow column. The borrow column, the values of 1, 2, 3 and 7 are high, others are 0. So write the values. This is 1, 2, 3 and this is 7. So all the 4 positions are filled, and now you can see that these 4 ones are adjacent to each other in all the directions. So what we can do is, we can make one pair with this 2 columns and one pair, another pair with these 2 columns, and we can have one more pair alone in this column. Okay, so this row make one, this row make 2 rows, that means this row make one pair, and this section of the row make another pair, and this column make another pair. Now, how to write the equation? B out is equal to, so first you write this a bar into b in. Okay, so here this is a bar and we are having b in. Okay, a bar b in. So for this expression, we here this is actually b bar b in bar and then b bar b in. Okay, so here this 0 and 1 get cancelled, only the second term remains, like, and that is actually b in. So a bar into b in. next it is actually take these two terms. Okay, in these two terms b in and b in bar get cancelled, the second term, and this remains. So actually this is a bar into b is common to both these terms, so this is a bar b, and finally this is the next term, which is the next pair. We can write here as b into b in. Here this, in this vertically, in the vertical direction, a gets cancelled because a has both 0 and 1. Vertically this pair covers both 0 and 1, so a get cancelled and remaining is b into b in. So we have to write the equation as b into b in. So that's all the equation for borrow. So how to get the simplified expression? First you have to write b out is equal to, write all the terms. Okay, so we are writing the terms from this equation b out, which is these four terms 1, 2, 3 and 4. Okay, so after that we have to write the combination of these terms, b in into ab plus ab bar, a bar b bar plus a bar b into b in plus b in bar. So you have to rearrange the equation and you have to write the common terms. Take the common term outside and you have to write out the remaining terms as usual you do in mathematics. So finally, instead of this we can write as a b plus a bar b bar. So this is actually a x nor b. Okay, and now here b in and b in bar get cancelled, so only a bar b is remaining. Okay, and this is also equivalent to b in into a xor b whole dash. Instead of x nor we are writing xor b the whole dash plus a bar b. Okay, so this is equivalent to the expression which is the output expression for borrow, which is b in and then a xor b the whole bar plus a bar b. Okay, so this is, that means this is the output from the two successive gates. You can see we have seen in the previous diagram, which is the gate diagram. You can see here the output from the two successive AND gates, and you have to sum the values, and that will give the binary, that is the which gives the borrow out value. Okay, so this is how the binary expression is formed for both the difference as well as the borrow in the case of the full subtractor. So whatever the equation is given, first you have to draw the truth table, and from the truth table you have to draw the corner map, and then we have to try to reduce the corner map using the corner map simplification procedure, and the expression finally what we got from the expression of the corner map is the simplified Boolean expression. So here also we have found out the same thing. We have drawn the truth table of the full subtractor. We have considered borrow as separate output and difference as another output. We have drawn two different K-map, and we also use the K-map simplification method to find the expression for both borrow as well as difference. Hope it is easy to follow, and thanks for watching.